We still do not fully understand the Milky Way, even though Earth is part of it. Even basic details, such as the number of stars or its exact shape, remain uncertain. Estimates suggest the galaxy contains between 100 and 400 billion stars, depending on the measurement method. Additionally, scientists have yet to confirm whether the Milky Way has 2 or 4 spiral arms, although the 4-arm model is currently more widely accepted. The main challenge is that observing a galaxy from within is incredibly difficult. It's similar to standing inside a room. You can't see the entire structure of the house. Dust and gas clouds in space also block our view, especially in the galactic center, an area astronomers refer to as the zone of avoidance. To study this region, scientists rely on wavelengths such as X-rays instead of visible light. Another challenge is measuring the distances to stars. Certain types of stars, like Cepheid variables, have predictable brightness levels that make distance calculations easier, but not all stars have these characteristics. To create an accurate 3D map of the Milky Way, scientists use the parallax method, which takes advantage of Earth's motion around the Sun to measure the positions and distances of stars in space. The European Space Agency's ESA Gaia Space Telescope has been operating for the past 10 years, gathering crucial data to create a 3D map of the Milky Way. With the mission of observing and measuring the positions of around 2 billion stars, Gaia provides detailed information about their movement, distance, and physical properties. Thanks to Gaia's data, scientists can study how stars move within the galaxy, helping them better understand the Milky Way's structure and evolution over time. The telescope uses the parallax method to measure star distances with greater accuracy than any previous mission. Additionally, Gaia helps determine the chemical composition, temperature, and brightness of stars, offering deeper insights into their formation and development. Through this project, astronomers are not only mapping the Milky Way in detail, but also uncovering new celestial objects, ranging from exoplanets to brown dwarfs and other mysterious bodies in the universe. The parallax method is a crucial technique for measuring distances in space. Gaia uses this method by observing how the positions of stars change over time due to Earth's movement around the Sun. As Earth orbits, our perspective of the stars shifts slightly, creating a parallax effect. By measuring this small angular shift from 2 different points in Earth's orbit, scientists can calculate the exact distance to stars with extremely high precision. Gaia performs these measurements on billions of stars with unprecedented accuracy, greatly enhancing our understanding of the Milky Way's size and structure. With Gaia's data, astronomers can not only determine distances but also infer the motion and positions of stars in space. This plays a key role in studying the evolution of galaxies and star systems throughout the universe. Data from the Gaia Space Telescope has provided crucial evidence about the formation history of the Milky Way, revealing that it has absorbed multiple smaller galaxies in the past. One of the most significant mergers occurred with the Gaia Enceladus galaxy around 8 to 11 billion years ago. This collision left a clear imprint on the structure of the Milky Way and contributed to the current stellar population. In addition to Gaia Enceladus, scientists have identified at least 6 other galaxies that were swallowed by the Milky Way, enriching its stellar system. These mergers not only shaped the galaxy's structure and evolution, but also influenced the motion of stars that we observe today. Notably, the Sagittarius galaxy is still colliding with the Milky Way. This ongoing merger could alter the orbits of many stars and may even trigger new star formation in the central region of our galaxy. Collisions between the Milky Way and smaller galaxies have not only changed its structure but have also played a key role in its evolution. These mergers may have helped shape the galactic central bar, a crucial feature that influences the movement of stars and cosmic material. Additionally, these collisions create ripples and disturbances in the galactic disk, potentially stimulating star formation. Some scientists believe that one of these events might have indirectly led to the birth of the Sun and the Solar System around 4.6 billion years ago. In this way, galactic mergers have not only reshaped the Milky Way, but may have also played a vital role in our own existence. Gaia has contributed to many important discoveries beyond mapping the Milky Way. One of its remarkable achievements is tracking the orbits of over 150,000 asteroids in the Solar System, helping scientists better understand their distribution and movement. Beyond the Milky Way, Gaia has identified more than 1.3 million quasars, extremely bright celestial objects powered by supermassive black holes at the centers of distant galaxies. Notably, Gaia discovered a black hole with a mass 33 times that of the Sun, located just 2,000 light-years away from Earth, a relatively close distance in astronomical terms. This finding provides valuable insights into the formation and evolution of black holes and their effects on surrounding space. Gaia officially ran out of fuel in January 2025, marking the end of its decade-long mission. However, its scientific legacy is far from over. The vast amount of data collected will continue to be analyzed by scientists for years to come. 2 major data releases are expected in 2026 and later this decade. These releases could provide further details on the formation and evolution of the Milky Way while also helping to discover new celestial objects. Gaia has revolutionized astronomy, and even though it is no longer operational, its contributions will continue to drive groundbreaking discoveries, expanding our understanding of the universe. Following the success of Gaia, the European Space Agency, ESA, is considering a successor mission called Gaia Near. This advanced space telescope will operate in the infrared spectrum, allowing it to overcome the limitations of Gaia when studying dense, dust-filled regions of the Milky Way. Scheduled for launch in 2045, Gaia Near will continue the mission of mapping our galaxy in greater detail. It will expand observational coverage and provide even more precise data on stars, planets, and the structure of the universe. By using infrared technology, the telescope will be able to peer through thick dust clouds that previously obscured many regions of space. This will allow scientists to explore areas of the galaxy that have never been seen clearly before.